So now for the following hour, we are going to have 4 presentations from 4 different researchers based in Latin America. And the goal of the spotlight sessions is basically just for you guys to hear about the amazing research that's being done in Latin America. Maybe you see something that interests you and you can go and speak to them. They're going to be here for all week. So yeah, in case you want to ask them about potential collaborations and things like this. So without further ado, the Alvaro Soto is going to, he's a professor at the Pontificia Universidad Catolica de Chile, in Chile. And yeah, let us begin.
Let's try again. No. There you go. Okay. Okay, well, hello everyone. Thank you for coming, and it's a pleasure for me to be here. Thank you for the invitation. And today I will tell you about the activities that we do in our artificial intelligence lab. I hope so. I know how to fix this, I guess. Okay, I hope now I can tell you then about the activities that we do in our lab. This is our artificial intelligence lab. We are located in Santiago, Chile, in a Catholic University in the computer science department. And at this point, we are 5 faculty professors working in this lab. We had around 20 PhD students, 27 master students, and we focus mostly in these areas. So we focus in cognitive robotics. So we do AI, but we do some embodied AI. We had also robots. We do perception, mostly visual perception, and also we are doing some text analysis. We have another line in what is called explainable artificial intelligence. So we create models that we try to also understand the internal representation of these models and try to understand why the model takes different decisions. And also we work on meta-learning. So we are trying to go beyond what the current convolutional model is doing that are mostly based on memory, and try to do some research on meta-learning. And we applied this also in different areas. At this point, had some application in recommender systems, astrophysics, and retail, and some application in healthcare. So today I will tell you briefly about some of the projects that we are going on in our lab. So on Friday, I will also give a talk on Friday morning where I will provide more technical details about this. So today is mostly some brief overview of different projects that we are doing. So I will start with this one, this perception for public spaces. So the idea here is that we collect a lot of images from the web, and then we tell humans to do some labeling, some rankings. For example, in this case, we had these 2 images, and we ask humans to rank which of these images is more safer or looks more safer. Yeah. And we did this for different attributes that you can relate to these images. For example, wealthy, boring, depressing, and so on. And so at the end of this, we had a lot of images, and with this relative supervision, and then we train a classifier. So a classifier that can provide a score about these attributes. So nothing really new about this, but the cool part was the way that we collected these images. So we used Google Street View to collect each of these images. And then, because we get it from Street View, we had some geolocalization of these images. And we collect these images from all over town, over Santiago. Yeah. And then, at the end of this classifier then provides us with a tool to score all these attributes all over the town. And using that technology, we can do visualization like this. Now, for example, this is the attribute wealthy. So you can see here that in Santiago, this is a map of Santiago. In the northeast part of the city is where all the people with more wealthy people live. You can also do this for the other attribute. So this is, I think this is a very cool application. You can do this for different attributes. For example, how clean is the city? What are the more parks in the city? And what is the architecture of different parts of the cities? So this is very important information for the people in charge of management of the cities. And you can do now this technology to do this. This is another application. This is text-based image retrieval. So the idea here, if you had a text, like a chef preparing a vegetarian dish, and you want to retrieve images related to this query. So in this case, what we did new is that we include in our model an ontology with different concepts about the world. For example, in this case, for the word chef that appear in the query, we can look in our ontology, and we can see in the ontology that chef is a person, and is located in a restaurant or in a kitchen. So then when we try to see the images that are most suitable for this query, we can, in this case, for example, use our person detector, because we know that chef is a person. This is something that we are working a lot. So we are trying to move beyond what is just what we can get from the deep learning models. And one way to do that is this one, try to put more knowledge in the process of the model. This is another application. This is in the area of visual question answering and with explanation. I will tell you about this. So in the computer vision community, there's a lot of interest in this application because it's very challenging for the model, and also it's a good way to combine all the visual part with another modalities, in this case with textual modalities. So in this case, for this application, you receive a query, a question, like what game are they playing there, and you get the image, and the goal is to provide an answer. For example, in this case, baseball. Yeah. So the usual way that you solve this problem is you get the image, and you get your convolutional neural network, and you move this image to an embedding, to some vector space. And you do the same with the textual information. You also get your convolutional network, and you move this to a vector space. And in that vector space, you try to see the image region that best correlate with the textual information, with different words. And you apply there a process that is called attention, the best image region that correlate with the words. Using that, you usually post this as a classification over the most frequent answer, and then you respond baseball. So what new we did here is that all this attention process here is unsupervised. It's the best correlation that emerge in the data, but all those correlations are based on a loss function that is based on a discriminative approach, a classification. So what we did here is that we include a direct supervision of what are the image areas that the model should look for to look for the answer. For example, in this case, it's like we are trying to teach the model that when you look at this image with this question, you try to find your answer here. But we provide direct supervision in that part. So what is the catch? The catch is that you need the supervision, and usually that is costly. So what we did for this is we use some information from the visual genome dataset. This is a very informative dataset with information about the visual world. For example, this is the one image from visual genome. And in this case, you had different regions. And for all these regions, you also had a description. So what we did here is that we get the question, and we try to see the words that appear in the question and in the answer, how are related with the description of the different regions. So for this example, we see that for this question answer, this region with this description, two men are talking, was more related to this person. So we assume in this case that this area was a good label, you know, or the region that the model should look for information here. So that's the way that we get this supervision. And this is a very big data set, so we get a lot of labels in this way. So as a result, this is, for example, for this question, what color is inside the cat ears? This is usually the ground truth where a human will look for to find the answer. This is a state-of-the-art model that's based on unsupervised attention, and this is the result of our model. So it's very good how it can learn an internal representation that is more related to the semantic behind the question pair. This is another application that, so we have 5 minutes more? So, okay, so this is an application in action recognition. This is an application in also navigation. We do application with navigation. I will skip this. I will talk about this actually in my talk on Friday. So what I will also want to show in these 5 minutes that I have is that besides doing research, another goal that we have in our lab is to try to move our research out of the lab to the real world, to application. So at this point, we had 2 spin-offs from our lab. I will tell you about one of them that is called Zippedi. And in Zippedi, our goal is to build robots for retail. Actually, this is the team for this spin-off. And most of the people in the team actually were people that previously worked in our lab in the university. So I will show you here a video that shows what is the goal of Zippedi.
De inteligencia artificial, el objetivo es mejorar la ejecución en el retail. En un supermercado pueden haber cerca de 30.000, 40.000 distintos ítems y que esté el inventario en la sala es una cosa que es una tarea titánica. Las tiendas pierden cientos de millones de dólares en el mundo en este problema. Creo que todos hemos vivido la experiencia de llegar a la caja del supermercado y darnos cuenta de que un precio está incorrecto, ¿no? Y tener que esperar minutos y minutos para que se solucione el problema. Si los precios están correctos, eso se evita. Lo mismo hemos tenido la frustración que llegamos a buscar un producto góndola y no está. Bueno, gracias al robot eso se ha disminuido casi a cero. En Zippedi estamos resolviendo 3 problemas principales. Uno, que el producto esté en la góndola. Segundo, que esté al precio correcto. Y tercero, que el espacio y el lugar asignado a cada producto sea el correcto.
Zippedi vino a transformar nuestra forma de trabajar. Este robot nos va prediciendo y nos va adelantando el trabajo y nos va ordenando cómo tenemos que trabajar. Somos mucho más productivos gracias a este robot.
Pero una vez que tenemos esa mente, ¿qué es lo que hacemos? Y ahí lo que desarrollamos fue...
Es Zippedi. Hola. Sí. Bueno, hoy día hay más de 50 robots funcionando. Esta noche van a salir en 50, ¿no? Oh, sorry. Sorry. So we have now more than 50 robots working in different stores, mostly in Chile, but also we have robots in Colombia, Ecuador, and in US. So the technology behind this robot are mostly 3. One is the autonomous navigation. No, the robot lives in this cage, and every night it go out of the cage and navigate around 3 kilometers, you know, to cover all the store. The other technology is the perception. Now the robot go around the store and try to see what is the state of the shelf And for that, it checks all the price tag. So it detects the price tag and also try to read what is inside the information in the price tag. It tried to detect the product and the configuration to see if there are probably problems such as out-of-stock problems. And the third thing is that the robot is providing all these measurements, but we also need to be sure that these measurements are useful for the people in the store. So we create also a bot that it coordinates all the activities for the people in the stores. Yeah. So, well, one thing that I just want to finish with this is that this type of project, we're going from the academy to the industry, in this case, to create a company. And sometimes this has some challenges that go well beyond what we usually have for writing our papers. Now, for example, in this case, this robot navigates every day more than 2 kilometers, process more than 150,000 images every night, and all are challenges. And also, we need to build the robots. You know? That's something that's very new for us. So it's very important to take care of this if you want to go from academy to a spin-off. So that's all my talk. I want to say thank you, Khipu, especially to all the people behind the organization of these events. I believe that artificial intelligence is now providing some technologies that opens a lot of opportunities to develop nice technology for different applications. And in Latin America, we need more events like this, like Khipu, to really put this to our students can really see all these technologies. So thank you very much to you.